So the formal definition of a complex number is an ordered pair of real numbers. So we can think of them as coordinates or vectors, if you like. X, Y. Complex numbers add like vectors. Multiplication is something different. They're commutative in that you can swap the order and you get the same answer. The real part of a complex number is simply the first coordinate. The imaginary part is the second coordinate. Real part of Z, imaginary part of Z. We call a complex number which has no real part a pure imaginary number, and that means that we include 0 as a pure imaginary number. The symbol I is normally used to denote the pure imaginary number 0, 1. So I squared is equal to minus 1. And if we use I to represent 0, 1, it's actually just quicker to write a complex number in general as the real part x plus I times the imaginary part y. Then we can get equations 1 and 2 simply by ordinary algebra. So the multiplication, if we multiply out those numbers, use this formula, just use ordinary algebra, then we actually end up with this formula here. So that's not so mysterious anymore. So the modulus of a complex number is simply the length of the vector. If we think of x, y as a vector, it's simply the length of that vector. The complex conjugate of a complex number is I'm going to use this Z star to denote it. It's sometimes also denoted by Z bar, as I've mentioned here. We get simply by changing any I you see to minus I. Okay, so if you've got x, y, then it changes to x minus, the complex conjugate is x minus y. More generally, if you have any expression and you want to find the complex conjugate of it, such as W equals P plus IQ, then to find the complex conjugate, all you do is you star everything. And if you see any i's, well, I star is minus I. So you just change the I to minus I. So another important relation is that Z times Z star is equal to the modulus squared. So we can see that from here. If we multiply Z by Z star, then we're basically multiplying x plus IY by x minus IY. And as you probably know, that's a famous result, which is x squared minus open bracket IY close bracket squared, which will give you the I squared will give you minus 1, and you end up with x squared plus y squared, which is simply this squared. So we end up with Z times Z star is the modulus squared. That's a very useful relation. If we add this 1.4 to its complex conjugate, then we end up with Z plus Z star is equal to 2x, which is the same as 2 times the real part of Z. And if we do Z minus Z star, the x's cancel, and we end up with 2iy, which is the same as 2I, imaginary part of Z. To divide, we talked about adding complex numbers. Obviously, subtracting is going to be fairly obvious. You just put a minus sign here. Multiplying, we've done. If you want to divide one complex number by another, the trick is that you multiply top and bottom by the denominator the complex conjugate of the denominator. So if you've got Z1 over Z2, you multiply top and bottom by Z2 star. Why do that? Well, that turns the bottom part into a real number. The modulus always has to be real, and that's how you do that. So you can do question 1, hopefully fairly straightforwardly. So the set of complex numbers is normally denoted by the symbol C. It's a blackboard C. You normally draw it as a normal C, like this, and then you draw one extra line down So just to notice that C includes all the real numbers. This is a slightly confusing language. We normally say that a number Z is complex if the imaginary part of the number is not 0. Otherwise, we say it's real. But in fact, the set C does include the real numbers. So just be aware of that. The set of complex numbers actually includes the real numbers. Although when we say a number is complex, it normally implies that the imaginary part is not 0.